Hello everyone. So today we are going to study the solid principles, but we are going to see the code in the Python. So basically what is solid? Solid stands for SOLID. Each letter have different meaning. S stand for single responsibility, O stand for closed principle, open closed principle, Liskov interface dependency inversion principle. So there are so many things that we are going to cover, but I am going to use an example which will be very easy to understand. So basically in the software industry there are some rules. If we follow these rules, our life will become easy. So basically I'm going to tell you what are the benefits of solid principle. So first of all, if we are using solid principle, it will be help us to improve our code. Okay, we can maintain our code. It will help us to enhance the stability. It can help us to enhance the scalability. There will be very less bugs if we are following the solid principle. We will better collaborate with each other and the testing will also become easy. So these are the benefits of solid principle. So that's why we all have to study solid principle. So we will go line by line and we will see each by example. So first comes S. S comes for single responsibility principle. So basically what does it says? It says that a class should have only one reason to change. What does that mean? Let's say we are making a class will have separate functions. Like this is a order class which have a function to calculate the total amount, to print the order or to print the invoice. So there are so many different types of functions that are present in the same class. Now let's say you want to calculate the final amount. So what you will do in the order class, you will call this function calculate total, and it will give us the final result. Okay, now let's say you have got the result on the screen. Now the customer is saying that okay, give me the printout or something like that, or you want to see the all the list. So what you are going to do, you are going to call this function, and okay, there is a print order function, we will call this function. Now this class have two function. Let's say in future you introduce a discount system. Okay, so what you are going to do, you are going to update this function that okay, whatever will be the total minus there is some discount. Okay, like this you are going to do. Correct. Now here there is a function print order. So here what you are going to do, you are printing the order. Let's say in future you require to store the details in the DB also. So what you will do, you will add one more function here. So what we are doing, basically there was already a class, but we were extending the functions. Okay. So depending upon the requirement, what we were doing, we were adding more functions, removing function, and we are doing lot of changes. Now what will happen? Let's say there is a function calculate total. You updated the discount, okay, here. So what you need to do, you need to check all the methods now, because there is a possibility that something can break. Okay, so to avoid this, what the single responsibility principle says us, that make a order class which have a function calculate total. This is a class, okay, which have a function related to calculate total. Make a separate class to print the order. Okay, so in future, let's say you want to print something in a different way or something like that, you can add more classes like this. Let's say you want to as we already discussed, you want to save the data to the DB, so you can make a class which will be save the data to the DB. So in this case, what you are doing, your class have only single responsibility. So if you see here, this order class have only single responsibility to calculate the total. Similarly, this order print class have only one responsibility to print the order. But in the previous example, what we are doing, we are doing all the things in the one class. So this is violating the single principle rule. So that's why we should follow like this. I have added one more image to show you that how what single responsibilities class shows to us. So basically it is saying that I am a chef, I am a gardener, I am a painter, I am a driver. Means this is a robot who is doing all the things, but this is not, this is violating our single responsibility principle. So there should be separate robot for each thing. So this is a robot for chef, this is a robot for gardener, this is a robot for painter, and this is a robot for driver. So like this we should have separately for each thing. Okay, it means a single class should only have one responsibility. So this is our first principle. Let's move to the second principle, which is open and closed principle. So open and closed principle means whatever the class we are having, function or module, it should be open for extension but closed for modification. It means once you create the class, we should not, there will be modification, okay, but we should write a code in such a way that the modification does not affect the existing function. I will tell you with the example. Let's say we have a discount class, okay, which has a function apply. So we have different types of discount. Let's say we are giving like 10% off, 15% off, something like this discount. Or there may be some discounts like we were giving a discount of 45 rupees. So there is a fixed amount discount, okay. Or there can be some other type of discount which can be incorporated in the future. So this is the one way in which we can make a class which have like different types of discount, okay. Now let's say in future you want to introduce some other type of discount. So what will happen? You will write one more condition, else if discount type is this, do this. But again, what we are doing here, we are violating this open close principle. Why we are violating this? See, we want to extend a different type of discount. That is okay. But here what we are doing, we are uh, changing the existing function. So what we need to do, instead of writing code like this, what we need to do, we need to write code like this. So we will make a discount class which has a apply function. Now what we will do, we will make different types of discount. So there is a class percentage discount where we are inheriting the discount, okay, class. So this is our base class. Now our child class will take from the base class as a reference and then we will apply it. So if there are any changes in the percentage discount, we can directly use this class, okay. This is a class where we can use fixed amount discount. So what we want to do here, so there here we have created different types of class. So what we are doing, we are open for the extension but closed for modification. So we are not touching this already presented method, that is percentage discount or fixed amount discount. Let's say in future you got one more type of discount. So what that will be combination of percentage plus fix. So what you will do, you will make a class here which will inherit the property, and again you can apply use this function. So here the chances of error, bugs and everything will be reduced, and this will improve your code. But here there is a possibility that if you are using like this, there might be some place where you forgot to, let's say you directly written instead of else if, here you written if again. Or there can be any possibility where you are again and again changing the value, you are applying discount twice. There is a possibility of error in this case. So to avoid that, what we need to do, we need to do like this. So we need to make a class module function which is open for extension but closed for modification. So it should be like this. So there will be minimum error. Now let's take another as example, another principle, that is for SOL, that is Liskov substitution principle. So what does this principle says? That subtype must be substitutable for the base type. So let's say there is a class, let's say this is a class bird and which have a function fly. Okay. Now if we are creating a class with this base class, let's say this is a child class, okay, sparrow is a child class which is taking the reference of this bird, okay. Now we know that sparrow can fly, okay, so this is okay. Now let's take another bird. We know that penguin is also a bird, but penguin cannot fly. But as we have taken our base class as the reference, but here the fly function is not applicable on the penguin. It means when we are using a class which is a parent class and we are taking a reference, it should use all the function which are available in the parents class. So here we are not allowing to use this what we are saying, fly function. So this is the wrong way. In this way we should not make our classes. So how we can do is, we can make a class bird where we can make a function move, okay. Now we can segregate like this. There can be flying birds, there can be non-flying birds. So flying birds, what they will do? They will fly, and non-flying birds, they will do swimming. Now there is a base class which have which is being used by two other classes, that is flying bird and non-flying bird. So instead of making classes like this, we should make classes like this. Okay, so now this will not violate our third principle, that is Liskov substitution principle. So whenever in future, if you see such type of scenario where the parents class some functions are not being used in the child class, or not making sense in the child class, it means the way you have written the classes, the way you have written the function can be wrong. Okay, I'm not saying that it's wrong. Means if you follow this technique, then you are on the safer side. So there is a bird class which can move can be of the fly or the non-fly or something like that. So like this, if you are going to create, you are going to handle all the scenarios. Now let's move to the next, that is interface segregation principle. Again, what is this class saying? What does this definition means? A class should not be forced to implement interface it does not use. Okay, now I will take you some example. Let's say there is some class which have some methods. Okay, now you are taking that class as the reference or the base class. Now there are some functions which you do not want to use it in the base in the child class. Okay, there is a parent class which have some functions, and there is a child class. Okay, now in the child class there are some functions which you don't want to use it. So you should not make a class, or you should not enforce to use all the functions. Let's take one example. Let's say there is a let's say there are we have two types of printer. One printer, you have seen that that is printing the documents, and there is also a function of scanning it. And there is a simple printer, what it is doing, it is just scanning the sorry, it's just printing the documents. Now let's say you are using this multi function device. Okay, so it have both the properties to print and to scan. But when there is a child class which is simple printer, which is taking reference of the base class, that is multi-functional device, so this has two function. Now as our printer is simple, which doesn't have this scan function, so in that case this doesn't make much sense. Okay, so what we are doing here, we are enforcing this simple printer to use this function. Which one? Scan one. Okay, but to avoid this, what we should do? We should make a printer class which is just going to print it. Now we should make the classes like this. There is a multifunction printer. Sorry, first of all, what we will do, we will make two classes. One is class that is for printer, one is class that is for scanner. Now our multi-function printer, what it will do, it will inherit both the classes, both the parent, these classes, printer and scanner. Okay, because our multi-function printer can handle both the things, it will do like this. But as our simple printer is using only one thing, that is its property is just to print it. So what it will do, simple printer class will inherit this class printer from this parent class. So here we are not forcing any of the class to use the function which is not being required. So this is the simple segregation principle. A class should not force to implement interface it does not use. Now let's move to our next and the last one, that is dependency inversion principle, that is known as DIP. So what does this mean? High level module should not depend on low level module. Both should depend upon the abstraction. Okay, let's take some example. How then we will understand what does it say. Let's say there is a class, Stripe payment or credit card payment. You can make any class like this, and there is at the checkout time there is a process of payment. So let's say at the time of checkout you are hard coded that you want to use this class Stripe payment processor. Okay, now what is being happen, this class is directly dependent upon this low level class. Okay, and this is high level. So this is the wrong way. Now what we should do is, now I'm again I have rewritten the same code again in a different way. So here I have created three different classes. One is the class for the payment process, one is the class For stripe payment process, again this is inheriting, or this is base class is payment processor, so it is using the same method, that is process payment. So here we have written a class for stripe payment process, and here we are using a checkout function where what we are doing, while this in the constructor we are saying that whatever type of payment processor you want, you can take it. So here we hard coded that, let's say now we have only one payment processor, that is stripe payment processor. In future, let's say you want to integrate UPI, or you want to integrate credit card or something else, so here this class will be, you need to change the entire class. But initially only you can define this class in such a way that while checkout, whatever payment processor you want to send, you can send it, and you can make the payment processor like this. So here can one more class can come, that it can be credit card class, again this will, then it will process the payment through the credit card. So like this you can do it. So here we have seen all the types of solid principles. I hope you like this video. Still, if you have any doubt, you can ask me in the comment section. Thank you.